In this section, we'll actually be showing the true power of regular expressions. And this power is reflected through the creation of descriptive patterns that we use when searching. This is known as form language. And the first useful thing we'll be learning is to create a recurring structure within our forms. To create them, we use several different characters, and they are the following. So we have asterisk, question mark, plus, well, actually, we're going to be doing it in this order, asterisk, plus, question mark, and curly braces. Where the curly braces, when we use them, we mention one or two integers separated by commas, whose meaning will be explained in this upcoming example. But first, we'll be defining a function that will help us, a simple function that will be used for our example. So we're going to define a function called all underscore matches with the parameters text and pattern. So we're going to be opening this method or function, whichever you want to call it. So print, we're going to have a print and pattern. This line makes it easier for us for reading the examples. Then we'll make a regex object, so variable called reg obj, and then we're going to say re.compile. Oh, I deleted the import re. That's better. So we're going to re.compile, and then we're going to make a regex object for compiling expressions. So pattern. There we go. And then we're going to have that's pattern. Then we're going to have a for loop for m in reg object dot find iter. This is another function. This is another function for finding certain iterations. All right, and for this line of code is going to do, this for loop is for every position, it writes from which position to which position there is a match. So, and then we're going to have, in that for loop, we're going to print string. We're going to typecast the string of the starting index, start. And then we're going to concatenate that with a dash, which we then concatenate with the end. So from start to finish, we're going to have m.end. And then we're going to concatenate that with a colon. So we're basically making this result look pretty. And so we can actually analyze it more easily. And we're going to concatenate that with text from the start to the end. And let's build that, just check. Okay, everything checks out. All right, so now let's move on to, let's do our examples now. So we're gonna call this function, so all matches. Oh, let's move this over first, sorry, there we go. And let's indent back, there we go. All matches, and then open parentheses. So now we have text. So this might be a little complicated, so give me a sec. So x, 2 y's, 5 x's, 1, 2, 3, 4, 5, 4 y's, 1, 2, 3, 4, 4 x's, 1, 2, 3, 4, 4, and 2 y's. And now we're going to be looking at our patterns. So this is where those different characters we mentioned at the beginning come in. So we're going to open our quotes, and then we're going to say x, y, and then asterisk. So what this expression identifies is it identifies samples that contain the x followed by 0 or more characters that are y. So let's print that out, and it finds all those samples. From this expression, it finds and it tells you where they are located. And now we're basically doing the same thing now, but with a different character. That character is the plus, as I mentioned before. So it's actually, we don't in order to save space, we'll just display one at a time. So plus, what this does, it identifies the samples that contain X followed by one or more characters Y. And then the next one, which uses the question mark, identifies samples that contain X followed by 0 or 1 characters that are Y. So 0 or 1. So here 0 or 1, as you can see. And then we have the curly braces. So with just one number defined, it finds samples that have X followed by exactly 2 characters that are Y. And then if we use two numbers, let's say 3 and 4, it identifies samples that contain X followed by at least 3 and no more than 4 characters that are Y. Excuse me, and there we go. So let's say we leave just one number with an empty comma. So let's say 2. What this does is it finds all the terms that have extended for at least 3 repeats of a certain sequence. So let's do that. So there we go. So it finds 2 or more. Okay, and so previous parsing that we've been doing is also called greedy parsing, because such behaviors to try to find as many coinciding strings to achieve the opposite behavior of the statements, which identify recurring structures, after which the character that defines certain amounts of repetitions can be put up, which can put up a sign as follows. So sorry if that didn't make any sense. So just think of this as before as greedy parsing, and the following we'll be doing is non-greedy. So this will be done with having our character from before with question mark at the end. So it doesn't try to find as many as possible. It just finds samples identifies contain X. So it's just non-greedy. All right, so then we use the same thing for plus. And then we get the same thing for question mark. So basically to do non-greedy, we have question mark afterwards. And then likewise, we have it for even for curly braces. And there we go. So if we leave one curly brace with a number, that would recognize all terms that have at least 3 repeats of a certain sequence, such as the following. So let's say 3, empty, and this is non-greedy version. So if we want to define more characters instead of 1, that can be the same place, we can do the following. So we use now square brackets. So when we do x, square brackets x, y, square brackets plus, this expression identifies samples that contain the x followed by 1 or more characters, x or y. So we can be finding x or y now. So we just basically get the whole thing. And if we can do so basically we do that if we want 2 other characters other than y. So moving on, to turn off the appearance of certain characters before defining these characters within the collection, it is necessary to state the character, this caret top right here. So if we wanted to, so let's do that with this example. So we're going to do all matches now. All matches. Now we have a different example. Let's say quotes xx dot dot space dot dot y 3 y's 3 x's dot dot space end of the string, and then the pattern is going to be the following. So we're going to have a quote, and then we're going to open square brackets, and then we're going to have the caret symbol dot space, and then we're going to have a plus. So what this does, it identifies samples that do not contain the character space and dot. So what we get is we get x, none of these dots, so we don't get any of this, and we get just this. All right, so we get, so we get this and we get this. So if we want to define a larger set of characters, such as all lowercase ASCII letters or all numbers, we can do it in the following manner without stating strictly all the characters. So let's erase all this, all matches. So now we're gonna have some weird string now. So we're gonna have A94, A94B2, lowercase c4, space, space, xyz, xyz, 08. And what we're going to define here is we're going to have, so we're identifying samples of all uppercase letters followed by digits, all digits. So we have, wait, A or Z, hold on a sec. Find, oh, that's because I'm missing the quotes, sorry. Quotes, so we need to define those quotes, and we get AZ09. Oh, that's because I have extra square brackets. There we go. There we go. So we get A9 and B2. So we get all of these. So all uppercase letters followed by digits. All right, moving on. Now we'll see for all uppercase and lowercase letters followed by digits. So we're just going to do the same. We're just going to copy this right here. So let's copy this whole thing. All right, copy that whole thing. Paste that. Whoops, I didn't copy it. There we go. So now we're, instead of this, we're going to have Z, and after the Z, A to Z. So we're finding all of the lowercase letters and uppercase letters followed by digits. Another useful sign in the form that is being searched is simply period or dot or full stop, whatever you want to call it. If this character is in the form, it can be replacement for any character. So let's get rid of this. All matches. And then we're going to have a thing called Silk Road. And then we're going to have capital S dot plus K. So this recognizes all sequences that begin with the letter S and ending with K. And we're going to get silk because that's the only thing in this example. So besides the previously manually defined sets, there are also predefined characters such as slash. We have the following. We have \D. We have backslash, which is digits, finding digits. We have capital D, capital D, which is anything but except digits. We have small lowercase s, which is white spaces, tabs. And we have capital S, which is anything but white spaces or tabs. And then we have W for alphanumeric characters, capital W for anything but alphanumeric characters, and that's it. So let's see that in an example. So we're going to use all matches again. And then we're going to say this, let's say this is first example. Just as and then we're going to say our pattern is, so we put the R sign, which means it defines forms as raw strings in Python, because if you pay attention to the escape character \, we have to put the raw, you make it a raw string, just for safe measure. So R, quote, and then our notation \D, D plus, for example. So all numbers. And then we have the same thing. Now let's do anything but numbers. So we only have a 1 there. So let's say D now. Build anything but numbers. So actually let's just replace it all together. Anything but numbers. So anything but numbers, that was. And then we have all white spaces. You just see where they're located. Then you have anything but white spaces, and you get their locations. And then you have alphanumerics, everything basically, except the dashes. And then we have and dashes, yeah. So, and then we have anything but alphanumerics, which are just spaces and dashes. So finally, we are going to specify tags for relative positioning of words in the string. So the following symbol, the caret symbol, whatever you call it, Shift-6, is used for identifying the beginning of the string line, and the $, that's not the $, is used for defining the ending of the string line. So /a, beginning of the string, and /z at the end of the string, and /b is empty string beginning, or b is this empty string at the beginning or end of the word. So that might confuse you, but let's just look at this in examples. So it'll be a lot easier that way. So relative positioning and regular expressions is our example. So there we go. In our patterns, we're going to use the R again, quotes, open our quotes. So now we're using the caret top, or caret, whatever you call it, and W plus. This finds words at the beginning of the string or line, which is relative, which is the first word, and then we can have /a, capital A, / this W plus, which is a word at the beginning of the string, which is that. And then we have W plus $, which is a word at the beginning of the string or line, which is not giving any results. But anyway, that's what that does. We have W plus /z, which defines a word at the end of the string. And then, oh, I just realized my error. I have the caret symbol in there, so that's why we're getting a mistake. My bad. So then we have A / W plus, which is relative, and then that's the first word beginning of the string. Then we have W plus /, which is expression, the first word with the word at the end of the string or line, which is expression. And then we have W plus /z, that's not /z, which is the word at the end of the string, which is the same result as before. And then we have /br /w plus, which is going to give us the letter R at the beginning of the word, and it tells us location. And then finally, we have /B G/B, which is the letter G in the middle of a word. So with that, we conclude this tutorial.